tell me in chat, do any of you watch the recordings or not? I'll wait for a second. I'd love to know. Okay, okay. I'm glad it's helpful then. But also don't hesitate to ask me, okay, if there's anything I can help. Oh, that is wonderful. I didn't know that. Do drop me a line and let me know, okay? Because of course the recordings record everything that we talk about here, so you can actually review it. But of course, if there's anything you need help with, don't hesitate to ask. I'm here to help. Okay, so let's continue. So here, you see, you do this select star from students, then you execute the SQL, and now I've got everything stored in this DF students, okay? So the simplest thing I would recommend in that case is just to return, not to solve the problem really, which I have done here. We'll talk about the solution in a second, but you can just take this and make sure that you just do return DF student, right? If you do return DF students, you can see what has come back from execute SQL. And that I think is always most important, right? Notice everything that I'm doing is to make it exploratory for you, right? Don't get stressed about the lab and the answer and everything. Let's just see what goes on. I think that's a nice way to approach new software situations, right? So we'll just say we'll return DF students and see what comes back, and then go to main, and then we have to execute that function. So to execute this function, you go to main, make sure that we have imported. So this is an important thing. We have to make sure that if you're going to use any of our code, as in these two lines, or if you're going to use any of the Python code, you have to make sure that things are imported as needed, right? So for example, here, if anyone is curious, you can ask me. I don't need you to dive into why I have to use this complicated way to, okay, I can tell you in a short way, the paths are a little complicated on this website, on this cloud hosted stuff. So, okay, so let's just go here, get back on track here. So we're going to run this max min DOB, and then let me comment out everything that's not needed. So that's one thing, print statements are extremely helpful to us because they allow us to see things. So let's see what happens. Okay. Return invalid syntax. So when I commented out stuff, I must have broken something. So I don't get fussed about things when they break. By the way, I want to share with all of you, the world of programming is full of broken things. So all we have to do is just go and see what happened, okay? So let's just go here. Yeah, there's an extra character here. So I thought I hit a comment here, but I hit an E instead. Okay, so now this should be all right. So then it fixed, we run it again. So reading those error messages carefully, trying to extract whatever is possible. Okay, OS is not defined. See, somebody had this problem. Somebody had this problem in their code. So now I know that OS is not defined. I'm letting the program break as much as it needs to, and then we solve problems as we go along, right? It is a skill that is so essential for all of us. I'm not saying all of you, notice. Okay, finally, success. And hopefully this is the moment when we celebrate for all the struggles we had up to this point, but we can actually see what happens. So it looks like we're getting all the records from a database. And that is basically a foundation for us now. We know how to connect to a database. We can run the queries. We can see everything inside codeboard. Our setup is correct. We are connecting to the database. The imports are correct. We're ready to go, right? So now we can actually start solving problems. Now, one thing that came up to all of you is I did change the return, right? And actually here, because we're going to do pandas analysis, before I just returned as raw Python data structures. In fact, it was a list of tuples. You can go back to the previous lab and look at it. We were not using pandas then. So I was returning a list of tuples. Here I said, okay, wouldn't it be nice if instead of returning a list of tuples, I returned an actual data frame. So I return a data frame, and now you can see the output of that data frame. Okay, so there are small details here. As questions arise, I encourage you to just explore, right? And then some of you have asked me, okay, what's the difference between the previous execute SQL and the current one, and so on and so forth. Okay, and there's nothing God-given about this script. This script is here to help you. So if you want to make it better, you want to suggest any changes to me, anything, we can always tweak it, right? It's totally open. Okay, now the second part of this is really important. I assumed maybe I should have walked through this more carefully. I assumed all of you are good at testing, which we would cover in a more basic Python course, but it doesn't hurt to spend a minute today just to talk about it. So normally when I have taken courses, especially programming courses, I have to submit my solutions, and then there's a black box grading tool that I have no idea how it grades my code. And then it'll keep telling me I have mistakes in my code and I have no idea what is going on. Why do I have a mistake? So I was trying to make sure that you don't have to feel that pain. And so I published all the tests here. So in this case, we're doing Pandas. You can go here and you can see the tests. And I don't have time today to talk to you about testing in general. If you need, let me know. We'll see what we can do about it. But for those who know testing, this is all very self-evident. So let me just get straight away to the test itself. So the test itself I have advertised is very simple. You can see here, the core of the test is this assert statement. The assert statement says what the test is looking for you to produce, right? It's looking for you to produce two dates, which if you read, of course, if you read the instructions, it'll tell you we should produce two dates here. It's looking for you to produce two dates. And if you look at the code here, they are actually strings. Okay, so we should produce two dates as strings. And if your function produces the right answers, then you will pass the test. If your function doesn't produce the right answers, you will fail the test. Notice there are a few tests to pass. And if you run all of them, you may fail many and it will produce a lot of noise. So when you run the test thing, it'll run all of the tests. If you find all of the test output a little distracting for you, just comment out. Just, comment out all the tests you're not interested in at the moment. And you can just focus on one thing. If the tests are complex, just put print statements in your code or in main, and you can just debug fairly easily. These are not complicated. There's nothing in our solutions here that are going to be more than, I think the largest answer might be 6 lines or so. If you're needing to use more than 10 lines, then maybe we should discuss the solution, okay? So let me come back here and just go back to the solution itself. So here is the actual solution to this problem. So I'll take out my comments and we'll talk about this. So the idea here is very simple. We could have just said, and in fact that was, I don't know if I have an older version of the code. It simply said, take the column and do max and min like this. So look here, if you look here, you can see database, date of birth, dot max. But that is max on any column can be run. So actually this code can be written fairly generically. But now, in fact, the first version I wrote would do max and min on any column in any table. So that was a nice flexible code, except there's a very strange problem here, which is why my grading had a bug. The data is actually stored as strings in the table, in the Pandas table. And if you sort it, it'll sort them as strings. So it's a simple little bug here. So we need to convert the strings to dates. So you convert them to dates using, okay, Pandas is beautiful. The story of dates is long. Maybe in the last session, I will talk a little bit about dates. But anyway, you can convert the strings to dates with a simple command like this. Then you can sort them. And finally, you have to produce an answer, which is back into a string. And there's this beautiful function, string from time, which takes a format string, right? You can say, I want a string which has the month, day, and year in it. And if you do all this, you'll be done, okay? After you do this, you just, I don't want to actually run the test, but to run the test, okay, I can run the test. Let's run the test and see what happens. Okay, so there are many broken tests, but we'll just focus on the top here. It could tell us, okay, that's why I said, if you don't comment out all the tests, you have to scroll through a lot of stuff. So you can see the test has failed for some reason. We can go in and look. Because I said return students and not the other thing. So let us just comment out this. Notice just, I don't have any superpowers. And as I make mistakes, in fact, maybe the best way for you to learn is to see that I don't have this super cool brain that just shows me everything perfectly. Okay, as you make mistakes, you deal with them one by one, and then finally you're left with the right answer, right? Okay, and you just, okay, I'm not sure I have the time to go through this slowly because I didn't prepare for this, but okay, let's see. Does anybody see it while I'm scrolling through this? I think because there's still a bug in the test file, it should be 8/10/1998. Did I not change the test file? It is, right? Okay, so let's take a second and the test file looks okay to me, right? Okay, so let's go back to main. Let's print it out. Like I said, there's no silver bullet here. You just have to do it slowly. And I think it's a good Zen thing to do. Okay, 10/23. So I think it's okay now. Okay, I probably won't waste your time debugging this. Okay, I will look at this after class and maybe when I send you a follow-up email on why that test didn't pass. Okay, I don't see it right away. But welcome to the world of coding. That's what it looks like. Okay, I didn't mean to make the test break to show you what it is. Okay, the only solution and the only way out and the master skill here for all of us is just to be patient and look at it carefully. Okay, and maybe I've missed something or a character or something like this. Okay, but what I would do is when I get time, I just sit down calmly, go through this loop. And I want to say the purpose of this loop is to return all of the knowledge and control to you, right? You don't depend on me. The code, Python, the tests, the compiler, the outputs, these are all your friends. You just need a little time and effort to get through all this, okay? Okay, so we'll see. If we have time at the end of the class, we can come back to this. But I have a lot of important stuff to cover today. So let's go there and then we'll see, okay? Maybe next class, okay, at the beginning of next class, definitely we'll go through this example again. Hopefully by then everything will be sorted out. Okay, so now let's go here. So I'm going to leave this page. Make sure you always save your work, okay? That is something, if you leave the page, it doesn't save it. Okay, so now here for today, let's just quickly go. Today we want to do some data analysis. So let's spend a few minutes. Okay, so quick couple of polls. I want to use some linear regression today for data analysis. So can some of you let me know if you know, have you studied linear regression? Do you know how to use it? I'll give you a second. Okay, only 3 of you have responded. Can I get some others to respond? I'll wait for another minute. Okay, all of you have responded by now. Okay, so most of you know it. So then I'll just, for those who know it so well, I would say, just sit back and watch. I will just show you how we can explore even a topic like linear regression itself, just as an exploration in Python, okay? Okay, have you started working on your project? I guess I have already done some work. Okay, most of you haven't. So I want to just say that it is important. I put the project in there only to help you. And the main thing that I would say is pick a topic that you find interesting, make it something that is aligned with your career goals, depending on what your interests are and your career plans are. And definitely try to make it something that if somebody says, do you have any experience with Python or what have you done with data analysis? You can actually say, yeah, I've done a project, and you can talk about your project or demo your project or something, right? So it can be truly helpful because when you're coming out of college, it's hard to demonstrate how much experience you have with things. So this is always a nice way to be able to demonstrate, rather than saying I take a course and I got some grade on it, you can actually show them some code or discuss a project. Okay, so it is really there to help you. If you need any help from me, let me know. Okay. Okay, so now let's go and get started. So as usual, if you click on this link to the live session, it will take you to the web page. Make sure you log in, and then let's launch your from this link, you can launch a notebook session, log in, and launch the session. Okay, let me know when you're ready. I'll give you 2 minutes to do this. Oh, I didn't see. Okay, somebody had said suggestively the Z. Okay, you should, thanks, Annie. On chat, you said it should be 08. Is that what it was? On codeboard, I had 8 and not 08. Okay. Okay, so I don't want to go back and start that whole thing again, but yeah, I missed it. So next time I'll just demo it with the 08, okay? Hopefully all of you can take care of that, and then you'll be all set. By the way, that string from time function is very powerful and can produce all kinds of formats. So you can just use the formats to get what you want. Okay, so how many of you are in your notebooks? Can you let me know once you've logged in and launched the notebooks? Someone? Launched. Okay, good. Thank you. Okay, so let's get started. So this is this will be a quick way for me to do some data science in a notebook, but also use the data science right now just to analyze linear regression as an algorithm. What is it? What does it do, etc. So if it's repetitive, focus on the Python aspects of this discussion. If it's new, maybe you will get something. Okay. So just we start running this notebook. So the first thing I want to do is spend a minute on random number generation, right? So it's a big topic, but actually with these libraries, it's fairly easy for us. So NumPy has a random number generator. You set the state of the random numbers, random number generator. You can pick any number of points you want. And what I've done here is add another parameter called scale, or yeah, scale is a good name, I guess. It allows me to increase or decrease the dispersion in the randomness, right? So it's in a couple of lines, we can create for ourselves a bunch of random numbers. In the next class, we'll talk about visualization. But as I said, I would start sprinkling some visualization into our notebooks so you can just see at least how helpful it might be. And the first thing you do with random numbers, I think, is you can run a lot of statistical tests on them, but at least you can visualize them. And you can start to see that these random numbers, even though they are random, are characterized by some kind of shape when you plot them as a histogram, right? And in this particular case, you start to see that they are actually normally distributed because we used a normal random number generator, okay? So we got it. You can see that it's pretty cool that we can get, you know, a nice histogram in a couple of lines of code, not too much there. But now let's go in a different direction. And, you know, I never tire of highlighting this fact, but you can think of any function in mathematics as encoding a relationship, right? A relationship between the parameters or the input variables of the function and the output variables of the function, right? And so we can write a linear relationship here. And of course, at least I've never seen it this way. You just try to understand for yourself what the role of M and C is. There are many ways of understanding it. But for today, I will just show you what we could do interactively in the notebook. Definitely let me know if these things are helpful or not. But what you can do is you can actually change. So I put these little slider widgets in. So it's interesting. The notebook can become an interactive experience for someone who does not know how to write Python code, right? And using these widgets, you can actually play around with stuff. So it's a nice little puzzle for you. You can try to adjust, come up with an algorithm that allows you to quickly line up the two lines by adjusting the sliders. Okay. You can, of course, try trial and error as one way, but is there a faster way to line things up? And we'll use this idea again later, okay? So far, so good. Any questions? How many of you lined up the lines? Anyone? Anyone? Even a no is fine. Someone on chat, were you able to line up the lines? Is it working or not working? Okay. Okay, so then let's continue. Okay, so the next thing to do here is we can actually, plot this line. So let's just plot this line. I'm just showing you here how we would generate the data to plot. There's a very nice function in NumPy called linspace. Linspace allows us to create linearly spaced points. So in this example, I take about 10 points or so from NumPy. You can vary all this. This notebook is designed for you to play with it later. So you pick out 10 points and you can pass all those 10 points through this function, right? So now the function has been written for us. We can get the points and we can now we can run this function with this data and we can create, the input and the output values, and then we'll get something simple, right? But the moment we add noise into this, so that's just a straight line with some slope. But now we can add noise into this, right? So if you now make this a noisy input and I add my random numbers in, so you can see that I can just modify this by adding in my random numbers. Then I could plot this, and what was a simple straight line now becomes dispersed, right? But obviously there is some kind of relationship here. The points are clearly rising to the right and so on and so forth. And I think this is a good starting point for us to say, well, when we go out in the world and we collect data, and especially if we suspect there is relationships in the data, then the data would look like this, right? There would be relationships. And maybe sometimes even the first thing you can do is make plots to visualize these relationships, okay? So then you extract the relationship between X and Y values, and then we are done, really, if we understand what is the exact nature of this relationship. Okay, so I think that in a small summary is a quick way for us to say, well, this is what data science is all about, right? It is about having some ideas about what we would like to analyze, collecting data, then trying to figure out what are the relationships that are in the data, right? And then there are various other, these are, this is set up for us to be able to extract this signal by using linear regression. There are other kinds of problems like classifying things and so on. And there are different approaches to solving each one of them. But again, I want to stress here, at the end, I will show you that we can solve this problem with 2 lines of code, but we should really take the time to explore and understand what's happening behind the scenes. And so the solution to extracting this is basically, if I could guess any line, and somehow if I could draw a line like this, and if I could come up with some function, we'll suggestively call it a cost function. If I could come up with a cost function that tells me how good my guess is, then I could keep adjusting my line until I actually get the cost function to be as low as possible. And then we are done, right? So hopefully, and typically, or hopefully, the cost function is something that has a minimum and we can get there. So the challenges happen when the cost function is not a nice looking function, okay? So you could take a minute and think about, if you had to make up a cost function, what would it be? And here is the answer, right? If you had more time, we could just take some time and go think about it. So the idea is this: if I have a line, then I could plug in any value of X and my guess for M and C, my current guess for M and C. That would give me a value of Y. then I could take the actual data point, subtract the 2 and square it. Notice we have to square it because otherwise positive and negative values might cancel them when we take the sum. And that's a very simple looking cost function. It's also very nice. It's just a quadratic function, which means it can be minimized easily, etc. Right? And if the predicted values exactly matched, if they could exactly match every one of the input points, then this cost function would be identically 0. Right? So, okay. So if you haven't done this in the past, you should spend some more time thinking about alternate cost functions and so on and so forth. They're not too hard to come up with, but they will have different trade-offs. Okay. So now what could we do? Well, we could use our old trick, which we did before. We could just go and say, oh, here's a bunch of data points. And maybe you can do this. If you change the slope here and so on, this line will move. And I'm helpfully trying to give you a cost function value here, okay? So you can try to actually minimize this line by hand, okay? By moving this around till it actually goes through. So I got some number here, but it'll take you some time to convince yourself that you actually found the minimum and so on, okay? And it's not hard to find the minimum as well. Okay, so that is the whole process. So let me pause before I go into actually how can we find this thing. Somebody let me know, is this demo useful? Is the interactive things useful, or is just doing everything in code better? Is the visuals useful? Anyone? Okay, okay. So yeah, just take some time. As you can see, these are not just black box visuals, right? The code that produced it is also there. If the code is a little complicated for this, don't worry about fully understanding the code. At least play with the interactive widgets and understand what the minimization actually is doing. And I'll give you a further visualization of this. Okay, so now you can go ahead and use various techniques to actually find the minimum, okay? But here I will just give you the conclusion because we're going to program this. The conclusion is the minimum is found when the slope is computed with this formula. And even though it looks complicated, the formula is fairly easy, right? You take every value of xi, you subtract the mean from it. You take every value of yi, you subtract the mean from it. And then that gives you the numerator, and then you divide or you normalize it by xi minus x bar squared, right? So, and that gives you the slope, and this gives you the intercept. Okay, again, it's very easy formula. So simple formula. Now, what we have to do is actually take this and translate this into some Python code, okay? And this notebook is written with raw Python. It would be a great exercise for all of you if you can take this and then slowly use either NumPy and or Pandas and redo some of this, right? So redo this analysis using more modern tools. I'll finally show you how to use a library to do this as well. So it shouldn't be too hard, okay? So anyway, but I thought it is important, at least in the first pass, to see what the code actually implemented looks like, okay? So if you run it, this is what you'll see, right? You have some slope and intercept, that's your code, right? And if you see, yeah, you can go back and see what values were encoded and see if this actually produced good numbers. I believe the slope and intercept are pretty reasonable, okay? Okay, so once you have this, now we can do something fun, right? We can say, okay, now that I know what the slope and the intercept are, if you give me any value of x, I can predict what the y value is going to be by using my function, right? And so this will give me the y values. So I can actually create a list of all the predicted values, right? And notice that's a pretty compact one-liner, right? It says, use your model to predict the answers for every one of the data points in your data set, right? And then we know what is the cost function. So we can actually take the cost function and we can print it out or something, right? So it's pretty easy. Or at least you can define a cost function which looks like this and print it out. So that's all nice, right? And then you can see, you know, if you change values of m and see how the cost function changes and so on. So it's very easy for you to visualize what is going on, okay? So play around with it. Now I did all this by hand, right? Just to show you the role of the relationships, the role of noise, etc. You can also, just before we get through here, you can also go back and adjust the scale parameter, right? So you can actually add a little bit more noise in here. That's why right up on top, yeah, sorry, I'm scrolling too much, but right on top, there's a scale parameter. You can use the scale parameter to disperse your data more, and then you'll see some degradation. So you have some nice flavor of playing around with your data inputs and understanding the algorithm. Notice this is not what we can do with real data, right? You don't want to adjust it and so on. But here you can actually do it. By the way, there is an entire field here in data science where people do things which are called adversarial data science. The idea is if somebody builds a model like this, you try to create a data set that will break the model, okay? And there are some very, like for example, here's a linear model, so any nonlinear data would break this model, for example. Okay, so now we switch gears and we say, okay, so we did all this by hand, but suppose, and this is what many industry experts would be doing today. Suppose we wanted to do all this using, you know, a pre-built library, what could we do? And the answer is, well, you can just, there's a scikit-learn library. You can just go there, get a linear model, for example. You can import this particular model from there. And then once you can instantiate this model this way, so not too complicated code, right? I mean, you just instantiate this model. And then the most important pattern here is to call fit, right? If you call fit on this pattern, there is a little trick here. I don't want to dwell on it. You should pay attention to the fact that the data needs to be reshaped for this model to accept it, okay? But once this model has been created, then it's very easy for us to run it. And then we can go ahead and, you know, extract the model coefficient, okay? So I think here in a small nutshell is what the libraries offer us. I do want to take a minute here to highlight to all of you that, at least in my mind, this is easy to do, but this is not where we get the most insights and knowledge, right? The insights and knowledge come from trying to explain these ideas to ourselves and to our friends and writing the code to illustrate all these concepts. That's when we understand stuff. And when these models, eventually they will all fail at some point because they are just that, right? They're just models, so they will fail. We will not understand too much if we just use them as black boxes. But if you have these deeper understanding of things beyond even the mathematical, right? The intuitive, the visual understanding of things, then lots of good things will happen, right? So, okay, so far so good. Let me pause for a minute. I keep asking for questions, but I don't know. Okay, I will wait for a minute. Any questions? We covered a very complicated topic very quickly. So I will wait for a minute and see, does anyone have a question or a comment? If it looked too easy, maybe it's an illusion, but I will wait for a minute. Anyone? I'll let these pauses hang in the air because it makes me feel like nobody's listening. Is anyone there? Mm. Okay. Okay. Okay, at least one person is there. Okay, let me get through this quickly. I will say to all of you that without interactions, it's not very exciting for me to try to talk to a camera, right? But okay, let's keep going. So I'll run through this stuff and then, yeah. So now that we have a linear model, we can use it. We can use it to make predictions. So the important thing here, though, is that all we have found right now is that the values are correlated. In order to actually extricate causation from these models, we have to do a lot more work. And causal models are very topical these days, but not something we can cover, right? So I would just say, yeah, just think about that a little bit and do your own research on the topic. So finally, yes, once we have the data, we can actually make predictions, as I said. And this plot here shows you how good your predictions are going to be, right? It shows you whether your predictions are good at all or not, okay? So you can go back, rerun this, see what happens to the quality of your predictions when noise gets stronger, etc. Then we come to a very interesting topic, which I will not cover. But the topic is we have to spend some time to analyze the accuracy of this model, right? And if you analyze the accuracy of this model, we can decide if we should change our model or not, okay? One simple way is to just look at how low the cost function has got. That's the basic thing we can do. Okay, so now just a simple example, I guess. I created a small data set. I will make a lab for this class at this weekend and post it, so you can try to do it. I'll keep it fairly simple so that you can finish it quickly. And then all you have to do for the lab is basically what I'm demoing here. So there is a data set here called employee data. And I provided you with a very simple function that reads it. Notice that I've done all this using raw Python. I will show you later that we can also do this again with Pandas, okay? But if you want to play around with reading and writing to files, these two functions will help you. So let's just visualize this data. And the data looks like this, right? And it's just take a moment, as always, to look at this data set. Basically, you have years of experience going on the x-axis in salary in units of $10,000. There's the obvious correlation that we would expect to some degree, at least in this data set. It seems that way, that as the years of experience increases, the salary increases, okay? And then we can go and we can say, can we actually fit this data and extract information from it? And the answer is yes. So if you just repeat, your notebooks, which I have posted online, don't probably have some of this stuff. But I will just show you what happens. So if you actually do it, you do get a prediction for the slope and the intercept. And it looks like this, right? So it's positively correlated. Our fit is reasonable, and you can do a lot more analysis. I just want to leave you with one simple thing here. This, I think, is a metaphor for what happens to all of us. When we try to pick up a new subject, there are going to be oscillations. Things are going to be very exciting and very challenging and so on. Hopefully it has a constant level, which is higher than 0, right? Okay, I had prepared some other stuff about gradient descent and so on, but I guess you're all experts, so I will not spend any time on it. I will just spend a few minutes. Maybe we can even finish earlier than the time. But I guess it will not be okay for us to do this without talking about Galton. Galton was the person who actually did the first linear regressions, at least in my little reading of the history of statistics, right? And so Galton's idea was actually beautiful and probably something we should all emulate, because his work stemmed from his desire to analyze a particular topic, right? And in particular, he was interested in analyzing the topic of how human traits are passed from one generation to the next, right? And he did something that all of us could do, but clearly he did it, and he did it a long time ago in 1885, right? And which was, he actually went around and asked people for information and collected a data sample. And you can see his data sample is small, 933 or so in size. And it's a treat for us to actually have the data sample that he actually collected, right? And that's what we're using here. So it's typically used in statistical courses. I thought I would include it because the historical element is interesting. But also emphasizes very clearly that all this work becomes interesting when we have a problem that we want to solve, right? And in his case, he had a problem. He wanted to understand how traits are passed from one generation to the next. So yeah, so we can get hold of this data. Again, the file reading code is fairly simple. So you can actually get this data. You can see that this data is very simple right now. It has the gender. So it says male. It tells you, who's in which family. It tells you the height, the father's height and the mother's height. And actually, if you read the history, Galton realized that because he was trying to do some kind of relationship, notice all his calculations had to be done by hand. There were no machines or calculators. At least he didn't have access to it. I think Pearson, who came after him, did have access to calculating machines. But anyway, so he had to do all this by hand, but he noticed one important feature, which is essential when we do data science today, which is to transform our data so that it is easier to model. And the first thing he realized here is that, male and female members of a species can have slightly different height characteristics. And so he came up with a kind of approximate idea to scale all female heights by this factor of 1.08. I do not know how he computed 1.08, but this is what he actually used, or at least that's what I can find in the data, right? So, but anyway, in general, this could all be done in a modern way. Find out a reasonable height adjustment, right? So that we can use the entire data set. So once you decide that you want to rescale the data, you should just we can go ahead and implement it. So this is a simple height adjustment function. We can run it over our data set and create, in this case, I've created new columns for the adjusted data, okay? And then you have all the data you need. So all you have to do is extract, the two values, the X and the Y values from your data, and it's done here. And once you have these two values, then you can just proceed and do the analysis. So notice again, I want to stress this, that the work that is done before we get to these few lines of building models is really, really important, right? And it's a little abstract and will take some effort, right? So I encourage all of you to find that balance, right? Rushing into just writing a piece of code is not enough. Even though we are in a class that emphasizes Python and analysis, it would be unfair of me to suggest that all of the excitement isn't just writing these few lines of code. Okay, we have to find that balance. And once I can say one more important thing. If you master these coding techniques, then when the time comes for you to write and do data analysis, rather than wrestling with code and bugs in code, you can focus your energies on the analysis task at hand. On the other hand, if your coding foundations are not strong or it's not easy for you to write this code, then when you're doing the analysis, you'll have to spend a lot of time at the code level, which is not ideal. Okay. So yeah, so use this opportunity. It's a fairly easy exercise for us now to walk through every line of this code, make sure you could write this code yourself. I would strongly recommend that you delete all my code and just rewrite it yourself. That would be a good exercise for all of you. Okay. So anyway, if you run all this, then you will get, let me make sure I run this. Okay. I have a small bug in my code right now. I will come back and fix this. Okay. So, but if you run all this code, then you will get a line here that is the output of Galton's analysis. Okay. And I have more analysis here, but I don't think we need to go through all of them. The main points to summarize is that you understand linear regression to some degree. You understand how to massage the data, and you can do all of your analysis in a notebook like this. Now that I've got this far, I want to say maybe this is a template for some of your projects. You can just run this, make a notebook like this for your project. Think about what data you want to collect, etc., and then just create a cloud solution. Describe your project. You should link your project to the solution. So somebody had asked me this question about when you do your project, even if you hit the submit button, you cannot update it. The text that is submitted on the code website cannot be updated, but the actual code that lives in the cloud can be updated, right? So you can continue to update your actual Jupyter notebook until the very last day, okay? And that's mostly what I wanted to cover for today. So we are quite ahead of time here. Are there any questions for me? This is the tough part, right? I did expect there would be a few more questions or interactions for us. I'm going to wait for, okay. Hayden's good for now. Okay, are there any other things I can help you with? Anyone? It would be nice to have a quick exchange. We have a little bit of time.
When anyone, just any comment in terms of format, in terms of presentation, in terms of Jupyter Notebook, whether you like instruction using Jupyter Notebook or not, any comment which we can use for making these classes more interactive. It seems like it's pretty hard to make anyone talk here. So just any comment.
Okay. 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 So yeah. As Manish said, you know, if we keep, it's a little hard for us as instructors to really understand, because for example, today I covered a very complicated topic. I decided to skip over gradient descent, but maybe somebody could have asked a question. So what you get out of this course is really, you know, huge. Maybe it's not the same in your other courses, but this course is designed to respond to how much you want to get out of it. We don't have an agenda that we need to check off 10 topics, right? So this interaction will help us to decide how far to go, how much to share, what to explore, etc. So I really cannot do any more to encourage all of you to be active and interactive, okay? And these are live sessions. Otherwise, I could have just recorded the videos and just run them for you, right? So the fact that, we get up in the morning and just like you have to, and we try to show up is because the interactive aspects of the class are of tremendous value to you. But reflect on it. Right now, the only interactive aspect that you're using heavily is the emails. But I'm okay for that as well. But, we should, because some of the questions you have would be also questions that your peers might have, right? So those discussions would be very valuable all the way around. Okay, just ponder it and let's see, maybe next time we can have a little bit more interaction.
Yeah, and it's okay, even if you say right now that I don't understand what a data frame is, that's fine. Even it could be like very elementary question, that's fine. It's better to ask question than not to ask and think that I don't understand anything. Just ask.
Yes, I think those are very helpful and useful comments. Yes, thanks, Manish. So please think about this, okay? The interaction is, even though it's challenging and it's difficult to ask questions, that's why maybe even chat makes it a little easier. You can just type it out, right? If you feel a little shy or anything, there are no bad questions or good questions. And even if you don't have questions, you can make comments, right? You make comments like linear regression was harder than I thought, or easier than I thought, or pandas is more challenging than I expected. Anything would be helpful. Okay, while we were talking, I did fix it. So basically, to fix that problem, there is a very important thing about Jupyter notebooks that I'll mention for you, which is that the cells all have interdependencies. And so, for example, here, there's this function f that is being used, and this function can be redefined along the way. And here, for example, this function has to be a 3-variable function. Somewhere along the way, I had defined f to be a 1-variable function, and then that will cause trouble. So there is a very, even though the notebooks are interactive and so on, sometimes I go backwards and forwards and run cells out of order, and the notebooks break, right? And this is well understood as an issue with notebooks. But it's an issue that can be fixed if we can be more and more disciplined, okay? But it's a challenge. Just a tip for all of you, that if you find that when you're running code in the notebooks, something unexpected happens, probably it's better to go from the top down and just look at how the state of your program changes as you run through the code, okay? So I did plan, okay, maybe since we have a little bit more time, let me just show you one more example, and then we'll wind up, okay, since there are not too many questions. So both of these examples are designed to show you that if you collect the right kind of data, it's amazing what conclusions you can draw, right? By the way, before I jump into this next example, I do want to make the last comment about Galton. The last comment about Galton is that this concept of the word regression, and that's why I said it's surprising that there are no questions or comments, because even the word regression is very interesting, right? It is not linear relation or something like this, it is linear regression. And why was the word regression in there, right? And the idea was that sparked all this discussion and analysis was the idea that if the parents are tall, would the children be tall as well, right? And that is a very important question. And this idea that the population mean is always kind of maintained, right? That people regress or the heights regress to the mean is an important idea, right? So do ponder it. Maybe you can read some of the history as well, which is important. Okay, so now the next example I have here for you is also interesting. It's just a question of collecting the data. But this is a very beautiful piece of work that was done by Hubble using telescopes at Mount Wilson. As a physicist, I find this beautiful. Hopefully you will find it beautiful too. And what was done was to measure the velocities of galaxies and the distances at which they're located, right? And the idea was that you can take this data and you can just look at the distribution. And as you look at this distribution, you can see that again, it's positively sloped. And what that means is the further out you go, so I'm saying what Hubble immediately saw was, or once he had the data, I was able to see, is that the further out you go, the faster the galaxies are receding from us. right? And the question is then, what is the slope of that relationship? And this is today known as Hubble's law, right? That the velocity is a function of the distance, and there's a constant here. And this constant is a very important constant in physics. And you might say, okay, why is this interesting? Well, this is interesting because this allows us, again, you'll see here from the analysis, that it's a simple least squares fit of this data. But what is interesting is that this analysis, in this case, will allow us to predict that the universe has a certain age, right? And we know today the universe is 13 billion years old. It's this kind of simple observational astronomy that gave us the first idea about the age of the universe. You will notice that the numbers here are fairly off compared to the 13.6 I told you. And the reason is that this data is very difficult to collect, right? And so this data has constantly been improved, and Hubble's estimates were much lower than what we have today. But that becomes a whole discussion of astronomy. So I don't want to plunge you deep into that discussion. I just want to highlight to you that it really, any field, right, which has data in it can be subject to some careful analysis. And the mathematics of the analysis is not, or does not have to be far too complicated. Having said that, when we want to go to algorithms, yeah, no, I didn't put it in the notebook because I wasn't sure everybody wanted it. And maybe, I mean, I can share it, or maybe I can make this into a lab. So when I sit down this weekend, let me think about it. Do drop me a note, and if you want the data or you want the code, we can always share it. Okay, I'll put one or two of these. So just to give you a preview, this weekend I will put one or two of these data sets on CodeBoard, so you can actually write the code and analyze it a little bit. Does that sound interesting? For the last lab, do some data analysis. Anyone? Okay. Okay. And of course, okay, good, great. So of course, this will be helpful to you in many ways. This will be helpful in your career as well. Linear regression is still a go-to model for us, mostly because it is very simple, right? And so it doesn't obscure more complicated model like SVM or something would make it very hard for us to visualize what is going on, and you'll have to spend a lot of time. Having said that, I want to make two comments quickly. The first comment is the mathematics that underlies all this and the statistics that underlies all this is worth the investment for those who are at least mathematically inclined. I would strongly encourage you to pursue that. If you don't go that far, at least developing intuitions by writing programs and playing with data and visualizing things and have an intuitive understanding and use the libraries like scikit that I told you is not a bad second place. But there is no substitute for investing some time in learning the mathematics. So that was comment number one. Comment number two, if any of you have interesting data sets that you want to propose, we can also try to, definitely include them in your project, okay? I will put one or two of these into a lab and then you can play with it. I think that was mostly what I wanted to cover. We still have a few minutes. Okay, then I won't hold you all. You have a little extra time to yourself today because I would say if you have the extra half an hour, don't get caught up in the day. Take 20 minutes to write some code and make sure that you absorb all the material that's in this notebook. Okay, and then you can send me emails with your questions and we can discuss it further. Okay, have a good weekend, and next week we will spend some time on visualization. And I would urge all of you start finishing off your labs, and of course, start working on your projects. Okay, thank you.